The use of underground feeder, or UF cable, for pool motor and light wiring was acceptable in the past. However, current electrical codes typically prohibit its use in areas subject to physical damage or moisture. While UF cable is designed for direct underground burial, it may not be suitable for the harsh conditions around a pool. A problem exists where the number 8 bond wire is not connected to the pool motor and it was never run to the filter area. This leaves the motor improperly bonded. A recommended fix is firstly, extend the number 8 bond wire from the pool to the filter area. Secondly, connect the number 8 bond wire to the motor frame. Thirdly, verify that the equipment grounding conductor, or EC, in the UF cable is connected to the motor frame. The purpose of the bond wire is to provide a low impedance path for fault current to return to the service panel. Without a proper bond, there is a risk of electrical shock if a fault occurs in the motor. The equipment grounding conductor in the UF cable does not provide an adequate bond, as it may have higher resistance than the number 8 bond wire. Consider replacing the UF cable with a more suitable type such as RHH or THHN, which are designed for wet locations. Also, inspect the other electrical components of the pool, such as the light and transformer, to ensure they are properly bonded and wired. The National Electrical Code, or NEC, mandates specific requirements for swimming pool electrical systems to ensure safety. Proper bonding and grounding are critical to minimize the risk of electric shock hazards. The bonding grid typically involves connecting all metallic parts of the pool structure, including the reinforcing steel, metal fittings, and equipment, with a solid copper conductor. This creates an equipotential plane that minimizes voltage differences in the pool area. Grounding refers to connecting the electrical equipment, such as pumps, filters, and lighting fixtures, to the earth through a grounding electrode system. This provides a path for fault current to flow back to the source, tripping the circuit breaker or ground fault circuit interrupter, or GFCI, and energizing the circuit. The size of the bonding and grounding conductors must comply with NEC tables and requirements based on the size of the overcurrent protection device. The NEC also requires the installation of ground fault circuit interrupters for outlets and equipment in the pool area. Ground fault circuit interrupters are designed to detect small leakage currents and quickly interrupt the circuit, preventing electric shock. Regular inspection and maintenance of the pool's electrical system are essential to ensure continued safety. This includes checking the condition of wiring, connections, and equipment, as well as testing the operation of ground fault circuit interrupters. Any damaged or corroded component should be replaced immediately. Swimming pool electrical systems are governed by Article 680 of the National Electrical Code. This article provides comprehensive requirements for the installation and maintenance of electrical equipment in and around swimming pools, spas, and hot tubs. Article 680 covers a wide range of topics, including bonding, grounding, wiring methods, and ground fault circuit interrupter protection. One of the key requirements of Article 680 is the establishment of an equipotential bonding grid. This grid is designed to minimize voltage gradients in the pool area, reducing the risk of electric shock. The bonding grid must connect all metallic parts of the pool structure, including the reinforcing steel, metal fittings, and equipment. The bonding conductors must be sized according to NEC tables and securely connected using approved methods. Grounding is another critical aspect of pool electrical safety. Article 680 requires that all electrical equipment associated with the pool be properly grounded. This includes pumps, filters, heaters, and lighting fixtures. The grounding conductors must be sized according to NEC tables and connected to a grounding electrode system. The grounding electrode system typically consists of a ground rod or ground plate installed near the pool. Wiring methods for pool electrical systems are also regulated by Article 680. Underground wiring must be installed in rigid metal conduit, intermediate metal conduit, or rigid non-metallic conduit. Direct burial cables are generally not permitted, except for low-voltage lighting systems. All wiring must be installed at a minimum depth below grade. Ground fault circuit interrupter protection is required for most electrical circuits in the pool area. This includes outlets, lighting fixtures, and equipment. Ground fault circuit interrupters are designed to detect small leakage currents and quickly interrupt the circuit, preventing electric shock. Article 680 also addresses specific requirements for underwater lighting fixtures. These fixtures must be listed and labeled for underwater use and installed in accordance with the manufacturer's instructions. Underwater lighting circuits must be protected by ground fault circuit interrupters. Regular inspections and maintenance are essential to ensure the continued safety of pool electrical systems. Article 680 requires that a qualified electrician inspect the pool electrical system at least once a year. The inspection should include a visual examination of all wiring, connections, and equipment, as well as testing of ground fault circuit interrupters. Any deficiencies must be corrected immediately. In addition to Article 680, other NEC articles may also apply to pool electrical systems. For example, Article 250 covers grounding and bonding requirements in general, while Article 300 addresses wiring methods. It is important to consult all applicable NEC articles when designing, installing, or maintaining a pool electrical system. Pool electrical systems can also be subject to local codes and regulations. These codes may be more stringent than the NEC requirements. It is important to check with the local building department to determine the applicable codes and regulations. Working on pool electrical systems can be dangerous. It is important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves and safety glasses. If you are not comfortable working on electrical systems, hire a qualified electrician. The NEC provides detailed requirements for bonding metal parts of a pool to create an equipotential plane. This helps to minimize voltage differences and reduce the risk of electric shock. The equipotential bonding requirements apply to all metal parts within 5 feet horizontally from the inside walls of the pool, and also include metal parts of the pool structure itself. The bonding conductors must be solid copper and of the specified size, typically number 8 American wire gauge or larger, depending on the size of the service. These conductors must be connected to all metal parts using approved bonding connectors. Metal parts that must be bonded include the pool reinforcing steel, metal deck equipment, metal ladders and handrails, and metal components of the pool equipment such as pumps and filters. The bonding connections must be accessible for inspection and testing. The NEC also requires that a solid copper bonding conductor be run from the pool bonding grid to the electrical service panel. This conductor provides a direct connection between the pool bonding system and the electrical grounding system. The NEC specifies the methods for connecting bonding conductors to metal parts. These methods include using bonding lugs, bonding clamps, and exothermic welding. The connections must be mechanically strong and electrically conductive. The NEC also addresses the bonding of perimeter surfaces around the pool. These surfaces include concrete decks, paved areas, and other conductive surfaces. The bonding requirements for perimeter surfaces depend on the type of surface and its proximity to the pool. The NEC requires that all electrical equipment associated with the pool be properly grounded. This includes pumps, filters, heaters, and lighting fixtures. The grounding conductors must be sized according to NEC tables and connected to grounding electrode system. The grounding electrode system typically consists of a ground rod or ground plate installed near the pool. The grounding electrode system must be connected to the electrical service panel. The connection must be made with a solid copper conductor of the specified size. The NEC provides specific requirements for the installation of ground fault circuit interrupters in pool areas. Ground fault circuit interrupters are designed to detect small leakage currents and quickly interrupt the circuit, preventing an electric shock. Ground fault circuit interrupters are required for all outlets within 20 feet of the inside walls of the pool. They are also required for all electrical equipment associated with the pool, such as pumps, filters, heaters, and lighting fixtures. The NEC also addresses the installation of underwater lighting fixtures. These fixtures must be listed and labeled for underwater use and installed in accordance with the manufacturer's instructions. Underwater lighting circuits must be protected by ground fault circuit interrupters. The NEC requires that all electrical wiring in pool areas be installed in approved raceways. These raceways protect the wiring from physical damage and moisture. Approved raceways include rigid metal conduit, intermediate metal conduit, and rigid non-metallic conduit. The NEC prohibits the use of flexible metal conduit in pool areas except for short sections used to connect equipment. The NEC also specifies the minimum depth for burying underground wiring in pool areas. The depth depends on the type of wiring and the type of raceway used. The NEC requires that all electrical equipment in pool areas be accessible for inspection and maintenance. This means that the equipment must be located where it can be easily reached and worked on. The NEC prohibits the installation of electrical equipment in locations where it is subject to flooding or other hazards. The NEC provides detailed requirements for the design, installation, and maintenance of electrical systems in pool areas. These requirements are designed to protect people from electric shock and other hazards. It is important to consult the NEC and local codes before working on any electrical equipment in a pool area. A qualified electrician should be consulted for any electrical work in a pool area. They have the knowledge and experience to ensure that the work is done safely and in accordance with the NEC and local codes. The NEC requirements for swimming pool electrical systems are complex and detailed. It is important to understand these requirements to ensure the safety of people using the pool. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Local codes may also have additional requirements for swimming pool electrical systems. It is important to check with the local building department to determine the applicable codes and regulations. The equipment grounding conductor is a safety feature that provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. This helps to protect people from electric shock. The equipment grounding conductor must be sized according to NEC tables and connected to the equipment enclosure and the grounding electrode system. The bonding conductor is a conductor that connects metal parts of the electrical system to create an equipotential plane. This helps to minimize voltage differences and reduce the risk of electric shock. The bonding conductor must be sized according to NEC tables and connected to all metal parts of the electrical system, including the equipment enclosures, conduit, and grounding electrode system. Ground fault circuit interrupters are devices that detect small leakage currents and quickly interrupt the circuit, preventing electric shock. Ground fault circuit interrupters are required for all outlets and circuits in the pool area. The ground fault circuit interrupter should be tested regularly to ensure that it is working properly. Electrical safety is critical in and around swimming pools. Water and electricity do not mix, and the combination can be deadly. It is important to take precautions to protect yourself and others from electric shock. Never use electrical appliances near the pool. Keep electrical cords away from the water. Do not swim during a thunderstorm. Have a qualified electrician inspect the pool electrical system regularly. If you see any signs of electrical problems, such as flickering lights or shocks, turn off the power and call a qualified electrician. Be aware of the risks of electric shock in and around swimming pools and take precautions to protect yourself and others. Regular maintenance and inspection of pool electrical systems are crucial for safety. This includes checking the condition of wiring, connections, and equipment, as well as testing the operation of ground fault circuit interrupters. Any damaged or corroded component should be replaced immediately. It is recommended to have a qualified electrician evaluate and repair any electrical issues with the pool.